All right, today we're going to talk about square roots. Square roots is something you've maybe heard before, maybe you've seen a symbol for square roots, but today we're going to dive into what a square root is, how we find it, how we use it, and that sort of thing. So when we talk about square roots, we're first talking about square. Right? When we think of a square is a four-sided shape, quadrilateral, that all sides are equal. And when we think about finding the area of a square, we're taking a side times a side. So that side and side we know are the same length. So if I was looking at this square that has an area of 25 feet squared, I want to think what value or what number multiplies by itself to make 25. That would give me a square of length 5. 5 times 5 is 25. If I have a square with an area of 81, same idea. What times itself would make 81? 9 and 9. So that's kind of where this idea of square roots stems from and generalizes from. It's a square root. A square root is the side length of the square. The square itself is the area of the square. So that sounds a little confusing, so we'll kind of dive into it here. So square roots. I have a table here. We're starting with an x value. Think of this x value as the side of the square. So if I took that side and I multiplied it by itself, or I squared it, so I took that x value and squared it, 0 would become 0. 1 squared, 1. 2 squared, 4. 3 squared, 9. 4 squared, 16, and so on. And I would get what we're writing here are called squares. Now, the squares, from 0 to 144, you should know. So let me slide that over so you can see. I don't know if I can get it all in here. Nope, wrong direction. There we go. So these are values that we should know and we should be able to memorize. So what we would call these numbers on the bottom, these are the squares. The numbers at the top would be the square root of the square. Meaning if I took this value here, 9, the square root of 9 is 3. The reason being that 3 times 3 makes 9. The square root of 25 is 5, because 5 times 5 makes 25. So that's our relationship here. So if I look, let me zoom back in for us. The root, if I take the root, the square root, and I square it, I get the square. So again, this is the root, should be the square root. And then 9 is the square itself. So when we're talking about a square root, it's that number that would be multiplied by itself to get the number we are wanting, or the square. So it's important to note that squaring and square rooting are inverse relationships. They undo one another. So if I take 3 and I square it, but then I unsquare it or I square root it, I get back to the original number. So that's kind of the relationship between squaring and square rooting. We do have a new symbol. This is the symbol I was referring to. You may have seen before. This is called the radical. It's the radical. The number inside of the radical is called the radicand. This is the number that we're taking or want to find the square root of. So this symbol tells us find the square root of 9, which would be equal to 3. So these are equivalent to one another. All right, so let's talk about a word here called a perfect square. Let's slide this over here, a perfect square. A perfect square, if a square is indeed perfect, what that means is the square root is an integer, meaning the square root is a nice positive or negative whole number. If we go back to our top table, all of these values I have listed in our x squared row, those are all perfect squares. They're perfect squares because their square roots are nice whole numbers. 1, 2, 3, 4, 5. It's not 4.2 or 7.3. It's a nice whole number. So these are perfect squares. Our perfect squares are 1, 4, 9, 16, 25, 36. If we had a number that wasn't one of these values, let's say the number 12, because 12 is not, it kind of jumps over 12. 12 has a square root, but it's not a nice number. So 12 is not a perfect square. A number does not have to be a perfect square to have a square root. It just means that if it is a perfect square, it has a really nice square root in that whole number. All right, so let's go back to these perfect square idea. Every number has two roots, which is kind of weird to think about. It has two roots because it has a positive square root and a negative square root. Let's think about that for a second. So let's say I want to know the square root, the two roots of 16. Well, based on our chart above, or just thinking what number times itself makes 16, we know that 4 is an option. But it also has a negative root of negative 4. Now, if you're thinking, well, how can it have a negative root? Well, negative 4 times negative 4 makes a positive 16. So negative 4 times negative 4, or negative 4 squared, equals 16. So we have a positive root as well as a negative root. If I look at 49, same idea. I have a positive root of 7. 7 times 7 makes 49. I also have a negative root of negative 7. When we talk about square roots and symbols, we have a way to kind of distinguish between the two. Okay, we have a way to distinguish. So let's look right here. The positive root, the negative root, or both roots. Which one are we referring to? If we see a radical symbol by itself, let's throw a 16 in here. So the square root of 16. This is talking about the positive square root of 16, which is 4. If we see this negative sign in front of the radical, we're referring to the negative root. So if it was like this is the negative square root of 16, which in our case would be negative 4. And then the last one, both roots. For both roots, we put a plus sign and a negative sign in front of the radical. The way we can read this is plus or minus, meaning do the positive or do the negative. So we would rewrite that symbol. And if it was 16, it would just be plus or minus 4. And that's how we would read that, plus or minus 4. All right, let's take a look at a couple examples. So in this one, square root of 25. It's referring to the positive square root because there's nothing in front of the radical. So this answer would just be 5. The negative square root of 100 is referring to the negative root based on that symbol. So I'm going to keep that negative sign and think of what times itself makes 100, and that's 10. And then if we have a fraction, we can do, well, it's first off, it's talking about both roots. The square root of 36/49, we can square root the numerator and square root the denominator, leaving us with the positive and negative, or plus or minus. Square root of 36 is 6. Square root of 49 is 7. So plus or minus 6/7. And we would want to simplify that fraction if we could. In this case, we can't, so we would be done, and this would be our final answer. All right, we got 3 more questions real quick. Example 2, square root of x squared. Before we talked about how square rooting and squaring undo one another. So if I square root a square, those cancel each other out, and they leave me with just x. Because think, if I took a number and I squared it and then I square rooted it, I'd be back at my original. If I had the square root of 4 squared, same thing. They cancel, leaving you with 4. Or if you think about it, 4 squared is 16. What's the square root of 16? It's 4. And then the last one, really, really important here. So hopefully you've watched this entire video. We can't square root negative values. We call these undefined. The reason I can't square root a negative value is a positive times a positive makes positive, a negative times negative makes negative, makes positive. So there's no way for me to end up with a negative value unless I multiply a positive times a negative, which if I'm squaring a value, it has to be the same sign for each number. So that is square roots.